Had some questions about these problems from 10.5, where we're going to convert this to, it's really the trigonometric form of a complex number. So we have 5 root 3 plus 5i. I have the answer down here so you can see what the answer is. 5 root 3 plus 5i. And so, first of all, our r is the square root of 5 root 3 squared plus 5 squared. So it's 25 times 3 plus 25, that's the square root of 75 plus 25, which is the square root of 100, which is 10. So that's where 10 comes from. Our theta, so we know that tangent theta is going to be the y value over the x value. So that's going to be 5 over 5 root 3, which is 1 over the square root of 3. So you can ask yourself, because I'm sure you've all memorized the charts, so tangent theta equals 1 over the square root of 3. Theta would be tangent inverse of 1 over the square root of 3. Now, fortunately, this one, they're both positive. It's the first quadrant. So what do we have? We have like 5 root 3 and 5. So somewhere like that. And so knowing it's first quadrant, our theta is going to be 30 degrees is correct, but that's in degree mode. They want this in obviously radian mode. So it's pi over 6. So now if you hadn't memorized the values and you had to go back and use the calculator to get this, that's a tough one because it's not going to give you pi over 6 unless you had a TI, I think it's 89, you could put it in exact mode, or the TI Inspire CAS. So that's how we get these values. It ends up being r times cosine of theta plus I sine theta. So it's going to be 10 times cosine of pi over 6 plus I sine of pi over 6. To be fair for this student, it didn't say that it needed to be in radian mode and not degree mode. And I've seen it represented in degree mode, especially when we do some calculations like trying to add or subtract them. Okay, and I'm going to go ahead and do the next one as well. I do have the answer on here. So convert the complex number to polar form. Same thing, so our r is going to be the square root of 5 root 3 over 2 squared plus negative 5 root 2 over 2 squared. So that's going to be 25 times 3 over 4 plus, the negative squares out, 25 times 2 over 4. So we have the square root of, it's 25 times 3 plus 25 times 2. So that's 75 fourths plus 50 fourths. So we have the square root of, what is that, 125 over 4. And that would be, let me clean this up a little bit. That's 5 times the square root of 5 over 2, which is what the student had, which is not what the answer key is. So I tend to side with the student on that one. In fact, I'm looking at the next phase. For our tangent of theta is going to be, again, y over x. And that's going to be negative 5 root 2 over 2 divided by 5 root 3 over 2. And that'd be like saying negative 5 root 2 over 2 times 2 over 5 root 3. And the 5s would cancel, the 2s would cancel, and what we have is negative root 2 over root 3. Now that's not one of the ones we normally memorize. So it's not 7 pi over 4 because tangent of 7 pi over 4 is going to be negative 1. So I'm wondering what happened in the programming of this problem. So let's see, I have to use my calculators. I'm going to do tangent inverse of negative 2 over the square root of 2 over the square root of 3. And just to put it in the right quadrant, we are Yeah, we are out here, down here. So it is that quadrant there. And I don't worry about the scalings. I'm just going with the positive x and the negative y. So we get our calculator out. And I'm betting the student is correct in this problem. So I'm going to go tangent inverse of negative square root of 2 divided by square root of 3. Of course, I could just do it under the same radical, but... And I'm getting negative 39 degrees, but if I add 360 to that, I get 320.764. So I'm getting approximately, well, negative 39.23152.048. And if I add the 360 to it, because they want it, doesn't say they want it positive, but I assume they want it positive, 320.7684795. Now, the one other thing about that, in radian mode, that's in degrees. And if I did this in radian mode, I'm going to multiply by pi over 180. And I get, or 5.5985 radians. So I'm willing to go with the answer the student had. So good job to this student. And thank you for bringing this up. That's z equals... You don't need the z equals, I don't think. 5 root 5 divided by 2 times cosine of either the 321, or you can do the 5.5985 plus I sine of 5.5985. So these are both correct answers, and this one's not. Okay, good job catching the error in the system.